Hello everyone, welcome to On Point Physics. Today's topic is physical quantities. So what exactly is a physical quantity? Anything that can be described using a number and a unit is called as a physical quantity. So there are two things to look out, a number and a unit. For example, length of an object is 10 centimeter. So here the length of the object is described by two things, a number which is 10 and a unit which is centimeters. So next is fundamental quantity. So what is a fundamental quantity? A quantity which can be described by its own without depending upon any other quantity for its description. It is self-sufficient in nature. As we can see, there are a total of 7 fundamental quantities. Next thing to also see is what is called as an SI unit. Now for example, length can be described in meters, in centimeters, in kilometers, and so on and so forth. So there is a need for length to be described in standard form, and it should be accepted internationally. That is why SI units is important. Now let us look at the fundamental quantities. So length is measured in meters. It can be described by a single letter M. So this will be the symbol. Mass is in kilograms, kg. Time is measured in seconds, represented by symbol S. Temperature is measured in Kelvin and represented by K. Now the important thing to note is K for Kelvin is capital, whereas M, kg and S are in small letters. Why K is capital? Because Kelvin is the name of a scientist. Whenever a unit is on the name of a scientist, its symbol will be a capital letter. Next is electric current, ampere, again a capital A because ampere is also name of a scientist. Luminous intensity is measured in candela, amount of substance in mole. Now let us look at something which is called as a derived quantity. As the name suggests, it is derived from the fundamental quantities. Basically, it is made up by combining two or more of fundamental quantities. Now let us look at some common derived quantities. First is speed or velocity. It is measured in meters per second. So its symbol can be written as meters per second. Similarly, acceleration is measured in meters per second square. It can be written as meters per second square. Next is force. So to find out which fundamental quantities can be used to derive force, we have to think about an equation of force. The most common equation of force is equal to mass into acceleration. So we need two things. First is fundamental quantity of mass and second is fundamental quantity of acceleration. Now mass is measured in kilograms. Acceleration, as we have already seen above, is measured in meters per second square. So the unit of force will be kilograms meters per second square. Exactly the same thing is called as Newton. And again, because Newton is the name of a scientist, it will be represented by capital N. Similarly, work and energy both are measured in joules. So it will be represented by capital J because joule is also a name of a scientist. Similarly, power is measured in watts, represented by capital W. Next is pressure. The formula for pressure is pressure equal to force divided by area. The unit of force is newtons. We have already seen it over here. The unit of area is meter square. So the unit of pressure becomes newtons per meter square. The same thing is also called as Pascal. So pressure is measured in pascals. Volume, as length is measured in meters, area is measured in meter square, so volume will be measured in meters cube. So that was all about physical quantities. Do you know what is the unit of density? Comment your answers below. Thank you.